Hello, today we are going to focus on adding and subtracting terms, and we're going to look at what terms means in a moment. So let's take an example like we had from before, the cost of different amounts of chocolate bars. So let's look at the story or the argument that we've got this time. We want to know the cost of 2 Mars bars, a Twix, a Mars bar, 3 Snickers, 2 Twix, and a Snickers. Now what's different this time? Well, we have multiple times that we're bringing up how many Mars bars we've got. We can imagine how this could happen if we have a bunch of people who want to all go into the shop and we're trying to create one shopping list. People are going to say the bar that they want, and they might want one that's already been mentioned. So we could easily end up with a confused list like this. And we want to, what we're going to do is write it in its simplest form, which means that we're going to gather all of our different bars together into groups. But to do that, it's a lot easier to write it mathematically. So we're going to abbreviate this into a mathematical sentence, just like we did before. So 2 Mars bars would mean 2M. A Twix, so we're adding up costs, so we'd add on the cost of a Twix would be a Twix is 1 Twix, which we would just write as T. A letter by itself means one of that thing, but you wouldn't lose any marks if you put in a 1 there. A Mars bar, so another Mars bar, 3 Snickers, plus 3 S for Snickers, plus 2 Twix, plus 2 T for Twix, and a Snickers, plus S for Snickers. And again, 1 Snickers is just going to be written as S as opposed to 1S. Now I have a bunch of chocolate bars and I want to know how many of each I've got. So what I'm going to do is count up how many Mars bars I've got. I have 2 Mars bars and 1 Mars bar. So in total I have 3 Mars bars. And I have 1 Twix and another 2 Twix. So in total I have 3 Twix bars. And I have 3 Snickers and 1 Snicker. So in total I have 4 Snickers bars. So this, if I'm going into my shop, is really the list I want. I want 3 Mars bars, 3 Twix bars, and 4 Snickers bars, and I want to know the cost of that total group of chocolate bars. Now, something that is obvious perhaps from this case is that we could only add up, if we were trying to know the total number of bars that we wanted, it wouldn't make any sense if we were making a shopping list to just add up all of these numbers and say that we'd have, what would be 3 plus 3 is 6 plus. We wouldn't go into our shop and say that we wanted 10 Mars Twix Snickers. We can't go into a shop and buy something that is a Mars Twix Snickers. So we can't just add different things together. We'd only be able to add up the Mars bars we've got and add up the Twix bars we've got and add up the Snickers bars we've got in order to find out how many of each there are. It wouldn't make sense to be able to add these different types of bars together to get 10 of some grouped together version of them. We couldn't go into the shop and ask for 10 of these. So we don't. And in mathematics, we don't do that either. So when we're adding and subtracting, all we can do is add up terms which have the same letter and also the same power. But I've been using this word terms a few times. So a term is each of these blocks that we would be adding together. So they're effectively like words in a sentence. So this is a term, and 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 this is a term. So they are effectively the words in our sentences. So these are terms. So Those are our words in our sentences, are our terms. Now, we also have already, we know that our letters are things that can vary. So the costs of our chocolate bars can vary. So we would say they are variables. And the numbers that we are used to dealing with, that we've done maths with for ages, are our constants. They don't change, so they are constant. But there's a special word for a constant that is sitting in front of a letter. So a constant that is sitting in front of a letter is called a coefficient. Coefficient. So a coefficient is a name for a constant, a number that is sitting in front of a letter that is multiplied by a letter or a variable. Now, all of this together, so a complete story or a complete sentence, is called an expression. So all of this, a complete sentence, is called an expression. And when we say that we can only add Mars bars with Mars bars and Twix bars with Twix bars and Snickers bars with Snickers bars, we say that we are adding like terms. So we know that each one of these blocks, each one of these words is a term, and we can only add up like terms. So we can only add or subtract like terms. I'm going to write that out for you now. So written out, we can only add or subtract like terms. So if we had 3 Mars bars plus 2 Mars bars, we'd have a total of 5 Mars bars. But if we had 3 Mars bars plus €5, we'll say, or 5 of something else, we would just have 3 Mars bars plus €5. We would not meaningfully be able to add up the 3 Mars bars with the 5 because they're different types of things, so we can't add them together. So that's what we mean by saying we can't add or subtract like terms. It only makes sense for us to count up the number of Mars bars we've got. It doesn't make sense for us to add up our Mars plus our Twix plus our Snickers into some amalgam bar. We couldn't go into the shop and buy that, so we don't do it in maths either. So we have 3m plus 5 is just 3m plus 5. We can't do anything about it. We can't do anything to make it simpler. That's as far as we can go because these are not like terms. Now, let's put this into practice in a few more abstract examples. So we're not going to have a story involved in this one, but the rules still apply. So let's look here. We have 3x minus 4y plus 2x plus y. We want to write this in its simplest form. We'll often be asked to just simplify this type of thing. So what I'm going to do is do what I did over here. You might have noticed I put a different symbol underneath each type of thing. So I have 3x and I have plus 2x, and I have minus 4y and plus 1y or plus y. Now, I have 3x plus 2x, so I have a total of 5x, and I have minus 4y plus 1y. Well, I have minus 4 of something and I add 1, so I end up at minus 3y. And that's as far as I can go. I can't add or subtract the x's and the y's because they're different types of things. X could stand for something and y stand for something totally different, and I couldn't add or subtract them together. Now, I will be able to multiply and divide them, but we'll worry about that later on. Next example, we have x squared minus 2x plus 3x plus 5 plus 2x squared. Now, a quick note on what x squared means. If I saw, I'm going to put this up here as a side note. If I saw 3 squared, I'd know exactly what it meant. It would mean 3 multiplied by 3. So if I see x squared, all it means is x multiplied by x. So it means exactly the same type of thing as it did when we were dealing with numbers. And this is important for algebra in general. anything that's true for numbers is also true for our variables, also true for our letters. Now, let's look at this. We have an x squared here. And where else do we have an x squared? We have an x squared there. So I put a straight line underneath them. For underneath my x's, this time I'll put a dot. And there's only 1 plus 5 here, so I can put a little squiggly bit underneath it if I want to. I wouldn't need to put anything underneath there when I don't need to add it up. But I have x squared, which means I have 1x squared plus 2x squareds. So in total, I have 3x squareds. Then I have minus 2x plus 3x. I have minus 2 of something, and I add 3. I end up at plus 1 of it, which means I would just write it as plus x. I could write it as plus 1x. I won't lose any marks for doing so. And I have just plus 5. Nothing has happened to the plus 5, so I just rewrite it. And now we can see why this structure that we've been using for doing our number problems, our constants type math, was so important, because now this is how we have to structure our algebra. We have to write down each piece all of the time as we go down. We have to keep everything in context. Now, final example. We just have some more powers involved here. So I have 2a cubed minus 4a squared plus 8a minus a squared. I only have one cubed thing. I have two squared things. I have two squared a's. And I have just plus 8a. Now, that means that the only stuff I can add up is our a squareds. So I'll just rewrite my 2a cubed. I'll usually write my highest power on the left and then going down as I go to the right. So my next thing that I would write would be the squared part. So I have minus 4a squared minus a squared means minus 1a squared. So I have a total of minus 5a squared plus 8a. I just rewrite here. So I have my highest power on the left, and I'm getting smaller as I go down to the right. These types of things are important for the same way as sentence structure is important in English. If we don't agree on how we write sentences, if we write them up or down or side to side, it would get very confusing as to how to read English. In the same way, we all agree on the order in which we write things. So you can see here I've written x squared, then x, and then a number. Here I've written a cubed, a squared, and then a. So the highest power, the highest indice on the left, and then going down to the right. And these norms, these ways of writing things are important for being able to read what we're doing in maths. And that's what we need